I'm Stewart Cheifet. I'm here at Erlang Factory with Martin Odersky, Joe Armstrong, and Dan Simon. So once I've been chatting with Joe Armstrong, and he told me that Erlang is the only object-oriented programming language that really isolates objects. Can you tell us a bit more about that, the conceptual model of?
Well, actually, it's a kind of 180-degree turn, because I wrote a blog article that said why object-oriented programming is silly, or no, why it sucks. and I wrote that years ago, and I sort of believed that for years. And then my thesis supervisor, Saif Haridi, stopped me one day and he said, "You're wrong." He said, "What?" He said, "Well, Erlang is object-oriented." And I said, "No, it's not." And he said, "Yes, it is." And he said, "It's more object-oriented than any other programming language." And so I thought, oh, why is he saying that? And he said, "What's object-oriented? What does it mean?" And he said, "Well, we have to have encapsulation. So Erlang's got strong isolation, or it tries to have strong isolation. It tries to isolate computations." And to me, that's the most important thing. I mean, if we're not isolated, I can write a correct program, and your program can crash my program, so what the hell? It doesn't matter. You have to protect people from each other. You need strong isolation. And you need polymorphism. You need polymorphic messages, because otherwise you can't program. Everybody's got to have a print myself method or something like that. That makes programming easy. And the rest, the sort of classes and the methods, that's just how you organize your program. That's abstract data types and things. And Alan Kay said, the big thing about object-oriented programming is the messaging. It's not about the objects, it's not about the classes. And he said, unfortunately, people picked up on the minor thing, which was the objects and classes, and made a religion of it, and they forgot all about the messaging.
Above all, inheritance very much became an absolutely defining feature, implementation.
And then the nice thing about the messaging is I heard at QCon, Dan Ingalls said it decouples the sender from the receiver. So you get these isolation properties. If you send me a message, I don't really need to know it came from you. It can have come from anybody. So I don't inherit all the kind of mess that you've got. And we can decouple things.
So the 180-degree turnaround reminds me a little bit of turnarounds in other settings, like in Haskell. Sometimes people talking about Haskell describe Haskell as the world's best imperative language because it has computations, imperative computations of these sort of first-class objects, I/O values, which has now been taken into other languages as well, much more, that C# and Scala and others. But it's interesting that you can obviously do imperative language programming with Haskell, and you don't think about that necessarily, but it is actually it's got some nice properties for doing.
So I think our languages are different to the extent that the big thing about Erlang is it was designed for doing fault tolerance, and the big thing is the messaging and the concurrency. The big thing is not that it happens to be functional, it's not that it's got a dynamic type system. It's black boxes. You go in, you do something, you come out, I don't care how you do it, basically.
I think the functional programming is an essential base for what you've built.
For certain ways of doing non-locking computation, but you can do them other ways as well. I mean, it's the shared state you need to avoid, not the fact that it's functional or non-functional.
Yeah, so one other aspect of objects is sort of in the similar tradition which led to Beta, another Scandinavian language, which is this aspect of nesting. So for me, essentially, the reason for object-oriented programming is that at the end of the day, you have to put your stuff somewhere. And it's just impossible to put everything on the top level. And if you put this stuff somewhere, then you might as well give these things nice properties. And certainly in the line of Simula, which led to Beta, they did that. So for me, that's it. And in that sense, certainly Erlang is object-oriented, in the sense that the other aspect of encapsulation is that you have an interface and then you have an implementation which is decoupled. So it just depends how do you want to organize your interfaces. In Erlang, your interface is essentially a very thin wire. You put messages in, which can be anything, and in other languages you essentially define what kind of methods you have.
But I'm not sure, I mean, a consequence of putting things inside things, nested boxes, is that the nesting can come incredibly deep. And so I was looking at Smalltalk and Erlang. Both of them have about, the Erlang distribution's got about 2,400 modules, and the Smalltalk Squeaks have got 2,600 classes, or something like that, order of magnitude. I could tell, if you're doing an Erlang system, I could tell you which of those modules are essential. I mean, it's code, init, error handler, 4 or 5 modules. With those, you can just make a complete Erlang system, plus the language. The rest, you don't need. In these modules, in code, there's like 20 or 30 functions. Half of them are unnecessary. You don't need them. So I can make that statement about Erlang. If you look at Smalltalk, I just cannot make that statement. I see 2,800 classes. What the heck is this? How can anybody manage that complexity? So a programmer spending all their time sort of dithering around. So putting things inside things will result in something that ultimately is extremely complex. So I think we need sort of flat black boxes with well-defined interfaces and a glue language. We've got to stop making programming languages that describe machine instructions. We have to make programming languages that describe protocols and connections, because we have to limit the complexity of what can be in a black box. Because if we don't, it will explode, and it has exploded everywhere, and that's what's wrong. So it's, I want a philosophy that will drive complexity out of black boxes and sort of...
But I'm not quite sure I buy that, because I think that it confuses...
You're wrong.
He's almost born. He's almost born.
To try a bit harder.
Do the sale.
Right. So you could have systems that at the outside have a very simple interface, at the inside they're incredibly complicated and deeply nested and things like that. And in fact, that's essentially often the things that provide you, in the end, the most value, the thing you can't copy because somebody really thought deeply and gave them amazing capabilities. I agree that often it's misused and you have a huge ball of wires hanging out everywhere.
Yeah, I mean, I just don't think we've figured out how to make components connect. I mean, the hardware people seem to have done it. You have chips and, you buy them, stick them on a printed circuit board and wire them up. They seem to, and that's because concurrency works. And this message passing, that's why it works.
In the history of object-oriented programming, this implementation inheritance, or implementation of inheritance of at least partial implementations, or mixing in partial implementations, has been a fairly dominant theme. Now, Erlang doesn't have that, and you would always delegate. You would always create processes which delegate onto other processes. Yes. And F# strongly de-emphasizes implementation inheritance. You can do it because it's there for .NET, but it's really one of the key things that we did with F# object-oriented programming was to turn it so that you didn't encounter implementation inheritance until the very last concept in your learning about object orientation, and you would people do use it, but it's relatively infrequently. Scala, I think you've taken a different.
Definitely
the exact opposite. You mix in
it's very much to components from the ground up, and very, very powerful component combinators.
So I'm a little uneasy with that decision. The way I try and describe this is one of the key things about functional programming or delegation, as you're using processes, delegating to other processes, is you can take complex components and put them together and build something very simple as a result. That the bigger thing built out of components is actually substantially simpler than what's lying behind. I'm sure you can do this in Scala as well. It's more about methodology and orientation, and to me, the key thing about that disturbs me about implementation inheritance is you see people taking what is already a complex base type and making something which logically is actually simpler, but because they're using implementation inheritance, it actually appears in the outside as being more complex. And maybe it's a misuse of implementation inheritance, but by focusing on it as a major technique, it's inevitable that people just create more and more complex things using inheritance and mixing. Mixing can potentially have the same.
So I give you a counterexample of that, and that's something I've been involved very much in, and that's the Scala collections, which have. So one thing that you don't see in other languages is that really collections are all encompassing. A string is a collection, a bit set is a collection, a vector is a collection, a list is a collection, a set, a map, everything is a collection, and they all have exactly the same operations. So overall, you have maybe 20 different implementations, maybe more, that are specialized for different things, and of course that would be unmanageable if a user had to know them. But they have exactly the same protocol, so you talk to them exactly the same. And they have exactly analogous types. It gets complicated when you talk about static typing. So if you said, no, we do not want implementation inheritance, we will rewrite 100 operations on 20 collections and make them look all exactly the same, I challenge you to find a programmer that can do that. You will not be able to do it without implementation inheritance. Mm-hmm. It's a crucial ingredient for something like that.
But I think one thing I think we're all making a mistake in is what I don't want to see is a world where you gain. You have, suppose you've got a lot of Scala programmers, and they write a lot of Scala applications, and they're living in this Scala world. Everything's fine and beautiful. And you've got a load of Erlang programmers, and they're writing their Erlang applications, and you've got a load of F-sharp people. And then we say, well, you've written this wonderful F-sharp stuff. You've written this great Scala. You've written this. I want to talk to your application. How should they talk? Oh, we can't do that. Oh, that's a complete mess. Oh, it's all wrong. And then we say, okay, how should we talk to each other? And we say, okay, let's agree on how we talk to each other. And we say, well, we can send nil in a message, or we can send enumerated types. Yeah, we'll agree on that. We'll send integers to each other. Do we agree? I mean, Erlang can send integers to Smalltalk because we both understand big nums, but maybe I send Erlang's integers to C, and it says, sorry, we don't actually do integers. We send 32 bits. And we can't actually agree on sending integers to each other. And then we have a great argument and a standardization committee, and we don't. So if you start arguing about what's going on inside my language and it's better than your language and we use inheritance and we got that, you stop arguing about how we talk to each other. And the more important thing is how we talk to each other.
That's right. I do feel like...
We don't have any standards where we all agree and we can all talk to each other.
I think by focusing on delegation and by hiding complexity and creating simple objects on the outside, that fits very well in the world of modern standards, where you, on the web service you're providing, or the or perhaps it's in the context of .NET or something, you're providing a component on the C and some other API boundary. Then it is a simple process of taking these simple objects, complex things behind, and providing a simple overall API to those things. And then you have got some hope of having interoperability between all.
But then we say we can't send higher order functions and things. We can only send ground terms and data types, and then it becomes, not as nice. We should be talking about how we send higher order functions that are independent of the programming languages, and how we send richer data types. We're only use a web service description language and XML to talk to each other, and everybody implements that in our own language. That's crazy. It's really ugly.
It's not necessarily so crazy. Of course, it's crazy if users are writing that as their interface.
Just look at it.
Yes, yes, but for instance, the process of implementing a web service in a language like C#, or take C# just to be neutral, is really straightforward and simple, right? I mean, you could just take a class type and you say we want this exposes various REST APIs, and you say this one's called food bar Z, and it's there, it's exposed, and I'm sure there's analogous things in Erlang
I can do that.
and Scala. So I don't think we should necessarily be so resistant to these industry standards for the boundaries, because it is actually more important to have standards, interoperability, and have our languages implement them. I mean, they may not be ideal. We may not.
But we're not very proactive there. We sort of the standards come and golly, we've got to implement this stuff. We're not. We're proactive in programming language. We're not proactive in the protocols.
Yes, and that's in the .NET case. Just on the local component boundary for .NET components, we initially that obviously came heavily from influenced by the Java and object-oriented design standards, and we were more proactive in getting things like generics into.
I mean, the thing that sort of worries me is I go to big conferences like QCon or something like that, Joe, and my first observation, if you view it from a helicopter view, is there's a large number of people walking around here talking, and if you I don't understand what they're talking about, because and if you listen to what they're talking about, they're going .NET, and he goes, and then there's another group of 400 people wandering around there. They're going JVM, and there's 2 or 3 people going sort of Haskell, Erlang like this, and these groups of people just can't talk to each other, and the interoperability between them is lousy. And
there are other sorts of people talking
common standards to interoperate.
There are.
But ask all the JVM people if there are interoperability standards. They'll say no, we can only do it here. .NET, and we can only do it here.
If you ask other people, they'll be talking about REST APIs, they'll be talking about service-oriented architecture, they'll be talking about WSDL as API descriptions, and these are good standard interface descriptions.
They are. If you take the word out, good. They are standard.
No,
I don't think they are good.
Well,
because they're not as expressive as your type systems. No, but if you were to have a type system to talk about that, you would come up with something much better.
but one of the features of being good is that they're sufficient, right? They're not necessarily.
I mean, if you look at XML DTDs, sort of more or less regular expressions, but they were okay, and then they replaced it by schemas, which are completely unreadable.
Of course.
Okay, let's start on
schema has caught on, right?
No, and then James Clark did his whatever he called it. I can't remember.
But for example, there is an implementation of Erlang on the JVM Erlang, and there are other languages that have been implemented on the VM. Isn't it one way to interoperate, to do interoperability between languages? Like the same thing Scala does with Java and other languages on the JVM. Same thing that Sharp with the
Yes, if you accept the different functional properties that you're going to get. The garbage collection times will be different.
I mean, we have interoperability on the local code level, which we get that in spades with Scala and F#. But these days, because I take that so much for granted, that might look different from an Erlang context, but I take that so much for granted, I'm more concerned about interoperability at the web and data programming standards. But yeah, so I'm not sure about your view of interoperability outside the Java context. I know you run on .NET as well, but outside those contexts.
Yeah, no, you're right. I mean, for interoperability of big systems, but they were really stuck with the protocols because the problem is, even if you have 30 people like us, we couldn't establish a new protocol.
And then you have an even worse problem when you come to build an operating system. You just fill it full of thousands of things which nobody knows what they are, and various combinations that are talking to each other. And nobody knows how they work, and it's just a complete mess.
Yeah. So I can see you're in this bind. Do you embrace these protocols as sort of a part of the core Erlang experience, or do you resist it and keep a sort of clean distributed? I mean, perhaps this hits you more because Erlang does have a definite view on distributed programming, which is it works extremely well, Erlang to Erlang distributed programming, and that's great. But as people move to applied distributed programming, they hit boundaries where they actually want to no longer be homogeneous, they want to be heterogeneous, and it's sort of, I guess that is a big question for Erlang at those
So the Erlang model just says everything in the external world has to pretend it's Erlang. Works very nicely.
For when people play
so it's complex. We've got people from React and CouchDB and all they're building their Erlang applications, and then when they're having coffee, you say, well, if we have to talk to each other, if we happen to be on the same platform, then we don't have to go up through the protocol stack over and down. We can just go whoomp whoomp, and it will be interoperable. And
interoperability is a lot easier in homogeneous situations.
Yeah. More efficient too.
And I think I gave some lectures to QCOM, and if you look at, I think there was a big mistake made in something like I can't remember, RFC 24 or something. It was the simple mail transfer protocol, where the transport protocol was defined in text, and with an ABNF grammar to define it, and then people sort of tend to reproduce earlier things. They cut and paste an old spec and change it a bit. If the original RFCs had been defined using S expressions, then you wouldn't have something like 4,500 different grammars between these components that we use. It's a dreadful mess.
Sort of talking about the sheer complexity of these
specifications. Write them all with S expressions or Lisp, whatever. It doesn't matter as long as you choose something that's reasonably expressive.
I think I must have the good fortune of working in the context of .NET or I'm sure Java as well, where teams of programmers have sort of made all those connections work, right? So I've used web services every day, right? I do use them all the time, and I've never had a single bug in the actual implementation of the protocol stack kind of level.
But then the whole world's not going to use .NET, you see. So, I mean, maybe.
We still web services that we use from Java or .NET. There are many operate in many other languages. So no, I think there is good interoperability, but it may not get the massive efficiency that you are looking for in a homogeneous situation.
And it doesn't sort of go into, it goes into networked components, but it doesn't go into the components on one platform. I mean, the organizational operating system isn't organized that way at all.
Right, yes.
I mean, you can't view it as a collection of components that you can send messages to.
Yeah.
So its organisation is much...
No, some components, even on local machines, are going definitely much in
Yeah,
that
they're going
direction.
that way.
There's a big move in user interfaces towards just effectively having the same split you have on the web, where you have HTML, JavaScript as the display language, and then core background components providing that. Just using that on the local machine as well is a trend, and so yeah, it is occurring more.
I think programming has stayed the same for 25 years because the architecture hasn't changed, and then the multi-cores and the permanent connection of people to the internet means distributed programming. I mean, distributed programming, when you are permanently connected to the internet, is as sort of the social networking, the file sharing networks and things are a reaction to that, and it's a reaction that's only 4 years old. So we don't know where this is going at the moment.
Absolutely, I believe this is a total game changer. We were talking at Microsoft Research just the other day about what are the big changes ahead, but I think that
we don't know.
The fact that we can assume in the programming context that the internet is there, or in many reasonable programming contexts you can assume it's there. I think that is a big.
Yeah, but I think like storage moving off, storage being why does, I mean, okay, swapping stopped, virtual page swapping stopped at your hard disk because you weren't connected to the network. There's no reason when you're permanently connected to the network why swapping doesn't stop at your hard disk. It should swap into the cloud. And then if you just smash your computer to bits, you've got one, you can go to anybody else's computer and just swap it back in, and you've lost the last page that was dirty or something. So why doesn't swapping go all the way into the cloud, where we can put? I mean, we can't do reliable storage on that machine because if I smash it, you're broken. But you can do more reliable storage in the cloud, and I think that's the need for programming languages which can express that in a sort of fairly simple way rises, where there was no need for that 5 years ago.
Right, exactly. Yeah,
so
I agree.
So, like moving to another topic, like how is it like you start with a language and you try to make it like kind of perfect, and this is the first release, and then you get more demand to more features. How is it like to grow a language and adding features later on to the language, like either by syntax or by libraries? How is it like? Like you have 3 different experiences.
Well, the oldest should start first.
Well, actually it's great fun because we're fortunate not having many people using the language, so we could change it all the time.
You definitely need a point. You need a time of that.
Yeah.
Definitely.
So I mean, Erlang must have had sort of 3 or 4 years of just me and then me and Robert sort of changing stuff, and then it had users, and then it was, I mean, we would just put stuff in, and if they used it, and if they didn't use it, we took it out again, and
it's definitely
we could roll a new system every 4 days or so, and do that for 3 or 4 years, and then freeze the decisions.
I'm sure we'll all look back and think that phase is a particularly enjoyable time growing a language.
Yes, and now, I mean, now, if you want to change Erlang, you've got the committees talk about it. You can't just sort of do it.
But sorry,
there's no worse curse than having too many users too quickly, because you will be locked in all the wrong decisions. And yes, it gets more and more difficult to actually redesign things in ways which are even only so slightly backwards incompatible. Sometimes we still take the liberty to do it, but it becomes more and more difficult. And then you have the problem that it's always so much easier to grow than to take out things. So you have to battle that again, that you don't want to become another huge language where you just get every 5 years you have a new feature set in there, because that would push the language over the edge also fairly. So it's difficult.
You talked about adding a tail call to the JVM, and it was something I was thinking. If that had been in the early days of the JVM, somebody could have added it in a day or something. And now it's a incredible difficulty.
Have to get things into the base platform early. And that's absolutely critical.
Because the security models rely on not being there.
Sure. Yes.
Yeah.
So, like, what were your solutions to their problem? Like, there's a problem once it's popular in the language, you can't change much. What did you do for example, Martin, in Scala, in growing Scala?
Well, we also grew fairly slowly. So we were out in 2003 with basically just us as users, and like Joe, we had a bit less, maybe 3 years before it grew really popular, and we couldn't really do much anymore. And there was a big redesign from version 1.0 to 2.0, and it was fortunately only after the redesign that really adoption picked up. So there we could essentially we had some migration. I think there was actually a migration mode in the compiler that would give hints how to rewrite stuff, that would detect incompatibilities and give hints how to rewrite stuff. But since then we're very much constrained. Yes, we are maybe a little bit. Well, theoretically, we're in a better position because we push so much in the libraries. But practically, it comes down to almost the same thing, because once you have a subset of core libraries, they become, in essence, part of the language, and you can't change them anymore. Yeah. So, in the libraries, maybe you can get away a bit easier with deprecating things, having a migration path where for some time you have the old and the new solution next to each other, and then at some future version you cut off the old ones. But it's fundamentally both. It's almost as difficult as changing a language.
So the actors library has been re-implemented by another open source community, right?
Twice, yeah. One is Akka in Sweden, and the other is Lift. Yeah.
So, Don, the same thing I guess you did with computation of expressions.
The whole experience of growing the language, first of all, feels very similar story to the one that Martin described. Certainly, we learned a lot from .NET about how to evolve library sets in the early versions. Being able to basically communicate to users why something is changing and give them time to give them one or two versions to make adaptions. I mean, we've up to now, up till Visual Studio 2010, F# 2.0, we have been making changes, and that was definitely our stabilization point, and it's sort of backwards compatibility from this point on. So we've had a good landing at that point. We gave ourselves 2 years from 2008 and 2010 to get the thing really sorted and stable. That's been great. So for me, I'm actually at the moment, just fantastically enjoying that sense of stability. The fact that we're not all the F# samples we're writing, just they will work, and they'll always continue to keep working. Right? That feeling that nothing's going to change in that base at that base level is really nice. So I feel we've got to a good point. But it's been a very exciting time growing a language.
Yeah, I think we saw. It's quite funny. The sort of users you get, early users didn't mind. I mean, up to even when you had hundreds of users, they didn't really mind if you just changed everything the next day. Because at that stage they hadn't written millions of lines of code.
Exactly.
And it's not the. I don't think even the people who are late adapters or anything actually mind if you change the language, but they do mind if you've written a million lines of code because they've tested it all. And it's the actual testing of the code that's the problem. It's not the fact you're making the change. Because if you make a change, it's better, they want to adopt it. But if they've tested it all and frozen it into something, they don't want to retest it.
We will certainly have very, very, very strict baseline on backwards compatibility from this point. So we won't be changing. We won't be changing in ways.
So one thing,
I'm happy with that.
So one thing language designers don't do, because when you start out and design a new language, you don't think millions of or lots of people are going to use it, right? So you don't really design into it the mechanisms for changing it and really.
Oh, we did. Yeah, I mean, right from the start. I mean, the obvious one.
But you just said it's all backwards compatible, so you don't have.
No, we don't have to now. But right at the start, we've designed in the obsolete. We'd be able to put obsolete attributes in the library, so you can put and user code can do this too. I mean, critically, that they can, as they design their libraries, they can just start marking things as obsolete, and you get a nice message in the third-party user code to say, I shouldn't be using that anymore.
But I think you need to. I mean, what I'd like to see we don't do. I mean, is integrate, say, the language with the revision control system, because if you rename a variable, right, and you submit it to the revision control system, and say, hey, this is a completely different version and a completely different program. But hang on, you've just relabeled a variable. It has no semantics at all. It's just to make it a bit more readable. If you correct a spelling mistake in a comment, revision control systems are sort of generic and apply to any programming language, and that's really stupid. So, they need to be much more smart so you can check what's really happening, not this superficial stuff.
So we'll have Erlang RCS.
I don't know. I mean, I would love somebody to write.
Erlang specialized.
Yeah. But I mean, because really, I think. Well, I think people do. I think people are. What they're doing is they're writing. First of all, they write a problem. They solve the problem, and then they sort of optimize this code and work on it, and the code becomes very efficient but unreadable. What I think they should be doing is specifying it with a domain-specific language or some higher thing, and then writing a compiler, and then changing the compiler because it's not efficient, because then they would have the benefits of a clear specification and a fast implementation. What they do is they don't keep these things separated, and the language doesn't really support them separating them like that. It should do. So it's.
First of all, thank you to the Erlang Factory for having us here. I think it is so wonderful they have this. They have this track. Well, first of all, they invited Martin as a keynote speaker, but they also have this wonderful track which called, what is it, Give Me a Break from Erlang. Something like anything but Erlang.
We're fed up with
it. For today.
Yes.
Where they invite people from, they invited me last year and I came back this year, and I think that's such a good thing to have at a conference, and it's a sign of a really healthy intellectual atmosphere at a conference, and so thanks.
Thanks. It wasn't me invited, but thanks for coming, and thank you for coming, Martin, because it's.
I wanted to echo that sentiment. It's great to be here, and I think it's really the first time that we have three sort of languages in the functional space, but very, very different languages together. Yep. And I think it's a great thing to do because I mean we have such a lot of work to do. There's this huge pool of Java and C# programmers and conventional programmers.
I think our programming languages are sitting in the bookshelves in shops together. There's lots of Scala books sitting next to Erlang books and F# books, and all those books are talking to each other when the shops are closed.
Honestly, looking back 10 years ago, who would have thought?
Yeah, that's right. Yeah. But really, we really have a lot of work to do, and anything we can do to learn from each other how to talk to these programmers, because we know that taking the initial initiations into functional programming is very difficult for lots of people.
So we need books.
So working together will help, and anything will help that. So it's great that we connect.
Yes, certainly I'll be running off to get a copy of Martin's book to learn all his tricks of the trade. I'm sure that will be. I'm looking forward to that. And I've got a copy of yours on my desk. So.
Yes, I haven't learned F# yet.
There's a book downstairs. Yes. Program F#. We'll pop by and get you a copy.
Thank you, Don, Joe, and Martin,
Thank you.
for being here for the interview.
Great, thank you, sir.
Thank you.